Okay, so before checking out the LLM thing in RASA, what we'll do is we'll first create a basic RASA bot and then we'll see how the LLM thing works in RASA. So for that, first we need to install RASA, and then to install RASA, we need to create a virtual environment so that all our dependencies and libraries are isolated and don't get mixed up with other things. So I've created a virtual environment using Python and activated it. And after activating the virtual environment, I installed RASA. You can install RASA by using the command pip install RASA. So once RASA is installed, we can just create a basic bot structure using the command RASA init. This command will create a basic bot structure which we can modify according to our needs. So it is asking, please enter a path where the project will be created. So I want the project to be created in the default directory which I am in right now. So I'll just press enter. And it is asking me, do I want to train the initial model? Yes. So as you can see, a basic bot structure is created and the initial model is getting trained. Once the model is trained, will one more folder will be created here, that is models, and a model will be stored inside that. So let's just wait for this thing to get created. By the time the model gets trained, let me just tell you about the LLM thing in RASA. So RASA introduced the large language model feature. Basically, the main aim was to make the bot intentless. Intentless means not completely intentless, but to use as minimal intents as possible. And to include LLM in a RASA bot, we cannot include it directly. We have to include it using pipelines. Using pipelines, we can communicate to the LLM model. And to do that, we here in the config.yaml file, we have to define our pipelines that we want to use. So let's just let this bot to be trained. Okay, so this is our config.yaml file. Okay, our bot is also trained. It is asking me, do you want to speak to the trained assistant on the command line? Right now, we'll just skip it. Okay. Getting back to the config.yaml file, to use LLM models, we need to specify the pipelines for the LLM models that we want to use, pipelines and the policies. Here we have the pipeline section. In this, whichever like LLM model we want to use or diet classifier or anything, we can specify here, and policies also we can specify here. Let me get back to the data folder. Here we have the NLU data, and here we have the rules, and here we have the stories. Okay, so let me just explain you first the domain file. Okay, in our domain file, what all things we have? We have first is our intents, then we have our responses. Responses are basically the utterances that the bot will give to a specific input of a user, and intents are basically like created to categorize or to generalize or to identify the input or like what the input is. Like we have a greet intent, we have goodbye, we have affirm intent, we have deny. So whenever a user says hi, hello, good morning or anything, greet intent is triggered. So to classify those things, we have intents. And for these intents, we have a training data in a nlu.yaml file, this file. So as you can see, we have a greet intent, then we have training data for this intent. Similarly, we have the goodbye intent and we have the affirm intent and all those intents. Okay, so these are the intents and these are the examples that we need to provide for those intents. And then in our stories.yaml file, we have the stories in which we have the like story paths. In that, Whenever our intent greet is triggered, then we perform the action utter greet. Whenever intent mood greet is triggered, we perform the action utter happy. So in this way, intents are used. Okay, so let's just create one more intent to understand it better. Let me go back to the domain file and see. Let's just create an intent weather, and let's provide utterance as well. We'll say utter weather. So we can just give a simple text saying weather is awesome today. Let's just save this. Then for this intent weather, we need to provide training data. So for that, in our NLU file, we need to create like a section for this intent, say intent, then the intent name. After that, we need to provide examples for this intent, and that will go like this. We can say, hey, what's the weather today? Or we can say just the word weather, or we can even say how is the weather today. Or we'll have one more example. Mm, can you tell me about the weather today? Okay, so we have provided the training data as well for the intent. Now we need to create story for that. So we'll just create a story as well for that. Story, we can say tell weather, maybe name of the story, and we can define our steps for the story. And the steps will go like whenever the intent weather is triggered, the action that needs to be performed is utter weather. This is the utterance that we created in our domain.yaml file, utter weather. Okay, so let's just save this. So after saving, we'll train a model by using the command RASA train. Once this model is trained, we can test it. So whenever we are testing a model, we can give any input, and if we say like weather or how is the weather today, if we give any like if we enter any input from these examples which we have provided, then the intent weather gets triggered, and whenever the intent weather gets triggered according to our stories, it should perform the action at a weather. That is, it should give a response weather is awesome today. So whenever I intent weather is triggered. So let's just see how it goes. Right now we are doing this just to understand how the intent works. After this, like this will help us understand better why we are using the LLMs to the pipeline and what is the like exact aim of the LLM in RASA, introducing the LLM in RASA. As I said, LLMs were introduced just basically the main aim was to make the bot intent less, or like intent less means not completely intent less, but minimal use of intents, as we need to provide large amount of training data for each intent. So let's just test it. Okay, our bot is trained. Just clear the screen and we can just test it using the command RASA shell. Okay, so as I was saying, the main aim was to make the bot intentless, as the intents may require large amount of training data. And this right now we are running it locally, so there's no issue. But if we want to host our RASA server somewhere, or we want to like host it on a server, then we need to bootstrap everything, and that will like consume a large amount of space. And that is like a tedious job to provide training data for n number of intents. As our chatbot grows or as our RASA model grows and we introduce new features, the training data will increase. So for to get rid of that, we use the LLM thing. So let me just show you how it works. Okay, so our bot is loaded. We can say weather. How is, we'll just ask the bot how is the weather. Okay, so when we entered the sentence, how is the weather? I intend weather was triggered, and then according to our stories, next action was action utter weather. So our weather, like this action was performed. Now, so now we'll try this thing using the LLM model. So to do that, first thing we need to do is go in a config.yaml file, and we need to like use some pipelines and policies. I'll just uncomment few of these pipelines and policies. To use the LLM thing, main thing you need to use is the diet classifier. So make sure you have like specified the diet classifier into the pipelines. And one more thing you need to make sure that you have uncommented is inside the policies section, the TED policy. So TED policy helps the RASA bot to communicate with the LLM to understand the uh, input and to classify it without using intents. So let me just uncomment few of this. Okay, let's save this. Please, after making sure that I have TED policy in my policies and diet classifier in my pipeline, I'm good to go to use the LLM in my RASA bot. So first thing I'll do is I'll go to my NLU file and remove this training data for intent welcome. Not only intent welcome, let's remove the training data for all the intents, whichever intent we had. Okay, so we don't have any training data now. Let's go back to our domain file and remove this intent which we created. Okay, now let's go back to our stories.yaml file. In our stories.yaml file, what we can do is we need to modify instead of specifying the intent here. What we can do is we can directly specify the input of the user. Like we'll say, how is the weather today? And say this. So whenever a user says, how is the weather today? Or can you tell me about today's weather? Then action utter weather should be displayed like the utterance which we created. Similarly, we'll just modify the stories for other things also, like we had intent greet. So we'll modify the stories for that. What was intent greet? Intent greet was whenever user says hi, hello, good morning. So we'll just say hello. Then whenever user says hello, then action greet, utter greet should be performed. And after that, we'll even remove this intent from here. Intent mode greet. So once utter greet is triggered, what the user might say, the user might say, I am happy, then action utter happy will be triggered. Similarly, we'll remove the intent steps for each of the stories and replace it with user input. Mm, I and here we have mood unhappy. In that case, the user might say, I am sad. Then we have intent here, intent of affirm. That is, user might say yes. Similarly, we have another story here. I'll just copy this. Um, okay, so we have modified the stories. Before this, we had in our stories we had the like intents thing, intent. Then we had the intent whichever gets triggered according to that the bot should perform the action. But right now performed we have directly performed like we provided the user utterances. So will be according to that our bot will respond now. So let's just train the model. So now our RASA bot is trained. After the training step is completed, we can test the bot using the command RASA shell. So before in the previous step, what we did was we used the NLU file to train our RASA bot. We provided data. Then in our stories we had the intents to trigger the actions. But in this step we have like completely removed all the training data from our NLU file. We have even removed the intents, and instead of intents we have directly specified the user input. So now our bot is running. We can test it by saying hello. Okay, so as you can see, the bot is responding with, "Hey, how are you?" We have not provided any training data in our bot. Neither we have like used any intent. Still, our bot is giving us a correct response. We'll just continue the conversation. I'm happy. So great, carry on. So as you can see, our stories are working completely fine without even the intents. This is because of the LLM model which we are using through our uh, pipelines and policy. That is the TED policy and the diet classifier. We'll just check the weather thing also. For weather also, we have not provided any training data. So I'll just say, how is the weather today? So yeah, our bot is working fine. Weather is awesome. Let's try it again with some other sentence input. Here we have provided how is the weather today. We'll just try with some other input, like we'll directly say weather. We'll say something else. Can you tell me about the weather today? And let's see if this works. Okay, so great. Bot is working completely fine. We have just provided one sentence for the like for the bot to understand, but it is using the LLM pre-trained models to understand this sentence. So any similar sentence, like anything if we enter related to the weather, then this action will be performed according to our story. So our LLM thing is working fine. So now let's see what are slots and how to extract slots, and we'll be even saying how to we'll be using entities to extract slots, and then we'll be displaying those slots. So let me just stop it, and we'll create a new bot and then we'll start with it. A slot is kind of a memory location where you can store your data for a longer period of time to we can store data which can be used later in the conversation. Suppose suppose we have a conversation with the bot in which the bot asks you your name. Then we can store your name in the slot, and that slot will be we can access it later and use whenever we need later in that conversation. So basically, slots are used to store data for a longer period of time. And one more thing we have is a entity. Entities are like, I can explain with an example. Suppose we have a sentence. We have an entity called city, and we have a sentence, we have a conversation with the bot saying, bot will ask you, which city do you live in? Then the user will respond with, I live in New York City. So in this, if we specify the entity in this, the city New York can be classified as an entity. And for that, we can extract entities using in RASA, we can extract entities by providing the training data to the RASA NLU. And then those entities can be stored into slots for further use. Let's see how to do it. First thing we need to do is we'll look into entities. First thing we need to do is define the entities in our domain file. Define the entities and define the slots and define the responses in our domain file. So first and foremost, what we'll do is define an entity called number. We'll be taking user's phone number as input. So we'll define an entity in the domain file called numbers. And for that entity, we'll provide training data in our nlu.yaml file. So I've created a new intent for called phone. And in this intent, I have given some examples for my entity number. While we provide the data, this is the format where we can specify the entities. The in square brackets we have to give the value, and in the normal brackets we have to give the entity name. So here we have a dummy number and name of the entity, that is number. So here we have few more sentences. This is my phone number, and here you go. I'll add one more, like say my phone number is, then in square brackets we have to provide the data and just give a dummy number, and then in the brackets we have to specify the entity name. You can give as many training examples as you want. Just make sure you follow the naming convention, like in the square brackets data, then the name of the entity. Okay, so we have provided data for our entity number. For this, we had created a new intent called phone. So whenever user enters a number, the intent phone will get triggered and the entity number will get extracted. So we need to also define this intent in our domain file, which I've done here, phone. With this intent, I have defined one more intent, that is repeat phone. And I have even given provided training data in my NLU file for the intent repeat phone. For this intent, I basically created to repeat the phone number. Suppose just to show you that the data is actually getting stored and we can access it later. Whenever the bot asks the user to provide the phone number, the user will give the phone number, and this phone number is extracted. This phone number is extracted as an entity number from the whole sentence. Then it will be stored into slots, and later we can access it. Whenever I say what is my phone number or repeat my phone number, then the bot will respond with the phone number that it has stored. I can add one more example here for that. I'll just say my phone number is. If I say any of these sentences, the bot will respond with my phone number. Okay, so that was the part of entities. Now this entity will be stored into slots so that later whenever I ask for my phone number or whenever I ask the bot to repeat my phone number, it it can repeat my number. So we should store it in the slots. Now coming back to our domain file, here we have defined a slot and the slot name is phone. So this is the uh, format in which we define the slots, the slot name, then we have to define the slot type. Here we have defined the slot type as text. You have different types for slots like text, then we have boolean, then we have any. Right now we'll be using text. Then influence conversation true. Whenever you set influence conversation true, uh, I can explain, like for example, the user start if the user starts the conversation, like whenever the user might not say always say hi hello, the user might directly start like say tell the bot that, hey bot, this is my phone number 1 2 3 4 5 6 7 8 9. In that case scenario, if we have set this influence conversation true, then the slot will be extracted from that entity. If you have not set the influence conversation as true, then the bot won't extract the entity from there. So that is the thing. Then we have the mappings here, slot mappings. For this slot, that is phone mappings, we have set the type as from entity and we have provided the entity name as number. This basically means that we'll be extracting this slot using entity, and that entity will be number. So whenever the bot encounters or extracts the entity number, it will store that number into the slot phone. So mapping, that's why we have put the mapping as from entity and we have entity name as number. You can put the mapping as from text as well. In different case scenarios, we use different things. Right now, we are using entity to extract it, so we have used it as from entity. This is like the most used thing because it gives us the exact data that we want. If we are using text, then it might store the whole text that the user is inputting. So this is a very effective manner to extract slots using entities. Okay, so this is how we define the slots. The slots will be extracted using entities. Okay, now we have to even define the responses. Responses in the sense how the bot will ask for that slot. So for that we have defined utterances. As you can see, as the last time I had told, the naming convention goes with utter and the action name. So for slots, similar thing we follow, like utter, then we write ask, and then the slot name. Slot name is phone. So utter, ask, phone. If we had a different slot, suppose if we had a slot city, then our response name would be utter ask city. Then we define the text, what should come after that. So whenever the user wants to, whenever the bot wants to ask the user his phone number, the bot will prompt this address, that is, can I get your phone number, please? So that is how we define the slots and entities. So, okay, so we have defined the slots, we have provided the training data as well. Now, either we can write a rule to extract the slots and entities, or the other thing that we can do is write stories. Stories is a very like convenient way, and it is very flexible. So most of the people use stories. So I've just written a story here, like a happy path. So whenever user says hi, hello, or good morning, anything, intent greet will be triggered. So whenever intent greet is triggered, the next action to perform will be utter ask phone. That is asking for the slot phone number. So whenever utter ask phone action is performed, whenever the address, whenever the bot tells that can I get your phone number, then the user will enter his phone number. Whenever your user enters his phone number, the intent phone will be triggered. Once the intent phone is triggered, then it will extract the entity number. We have given an example for that. And then the slot will be set. Slot, that is phone, will be set to a number that will be extracted from using entity. So once the slot is set, then we perform an action, that is action save phone. This action we have defined in our custom actions, actions.py file here. We'll go to it now. So this action basically checks where the slot is empty. If the slot is empty, it will say that, sorry, I don't know your number. If the user has entered his number, then it will just prompt the phone number. So before you using this story in our stories, we need to even define this action in our domain file. So here I have done it in our domain file. As you can see at the bottom of the file, I've defined actions, and in that actions I've written the action name, action save phone. This will just prompt the phone number. So in our stories, whenever the slot is set, whenever the entity number is extracted and the slot phone number is and it is stored in the slot phone number, this action will be called, that is action save phone. Now coming back to the actions.py file, in this file we have defined the custom action. In this file we have defined the custom action to repeat the phone number. So the class name is action save phone and it is type of type action. And here we have defined the name. So whenever action say phone is called, this part of the code will get executed. So what it does is basically it will first use the tracker to get the slot phone from the bot. So and this slot phone, the value of the slot phone is stored in the variable phone. Then in the next statement, it will check if not phone, if the variable phone is empty, then it will just dispatch a message to the bot, text message to the bot saying, sorry, I do not know your phone number. If there is a value in the slot, then it will dispatch a message to the bot saying your phone number is, and it will prompt the phone. Just Okay, so one more thing we need to take a note of is whenever we are using entities or slots, we need to define some pipelines. We need to use some pipelines so that the bot can extract entities. For that, the most important thing is our diet classifier. If we have the diet classifier, you can if you have like used the diet classifier pipeline, then it's sufficient to extract basic entities from a sentence. So just make sure you have added necessary pipelines according to your needs. And yeah, that's it. Then we can just train the model before testing it. Sorry, to train the model, the command is RASA train. This will train the model. This will train the model for all the components that we have used in our config.yaml file on for different pipelines. It will take some time. Yeah, till this thing gets trained. Let me just tell you one thing. Yeah. So as I had said earlier, for actions, whenever we are using custom actions, we need to run an action server separately from the RASA server. So right now, once our model gets trained, then we need to we need to start a RASA server on a terminal. Then we need to open a new terminal, and in that terminal, we need to start our action server, and that action server will run on the port 5055. And to make sure that our action server is connected to our RASA bot, we need to check whether we have added the action endpoint in our endpoints.yaml file. That is here, action endpoint. And we have to specify the URL for the action endpoint. Right now we'll be running it on localhost. So localhost, and it will be running on port 5055. So localhost port 5055. So once you have checked all the configurations and everything and your model is trained, we can start the RASA server. We'll interact with the RASA bot on the command line itself. So we'll use the RASA shell. Our RASA server is starting on port 5005, and it is loading the model which we just trained. As I said, all the models that we train get stored here in our models folder. And as you can see, we have so many models trained, and it will start the latest model that we trained, that is this, because we didn't specify any specific model, so it is by default, it will take the latest model that is trained. By the time our RASA server gets started, we'll just open up a new terminal and start our action server. We have opened a new terminal. Please make sure that your virtual environment is activated even in the new terminal. If by default it doesn't get activated, then you can activate it using the activate command from the directory where you have created your virtual environment. Okay, so I've opened up a new terminal with my virtual environment activated. So to run the RASA action server, you can give the command RASA run actions. This will run the action server just normally. If you want to see the logs as well, if you want to enable the debug option, then you can give the command RASA run actions, and you can give the flag to debug. This basically helps you understand more if you encounter any errors or any blockers. So we'll be using this, and this also helps you to know when the action is triggered or executed. Let me just run it. Okay, so our action endpoint server is started, and action endpoint is up and running on the port 5055, which we specified here in our endpoints. Let's go back to our RASA server. Okay, the bot is loaded. Now we can have a conversation with the bot. Suppose I say hello, the bot should ask me my phone number. Okay, so can I get your phone number, please? Yeah, sure. So I'll enter dummy number. So once I enter a number, it should extract the number and store it as a slot. And yes, your phone number is blah 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 blah. So let's just see if our action got triggered. Yes. So as you can see, received request to run action save phone and finished running action save phone. It got a request to run the action and it executed successfully. So yeah, so that is how an entity is extracted and stored in a slot. To understand this in a more better way, we'll just run the bot once again, but this time we'll be using the RASA interactive command to talk with the bot. This command basically helps us to control the conversation of the bot. And we can even use the command, we use this RASA interactive command to train the bot and create stories from the command line itself. But right now we'll just use it to visualize the entity extraction and the slot storing. It is loading a model. Let's just check if our RASA action server is still running. Yeah, it's running. This usually takes a lot of time. Okay, let's just give it some time. By the time this gets loaded, let's restart our action server. Okay, so our action endpoint is up and running. Let's go back to our action server, RASA server, and see if it is started. Not yet. Okay, RASA server is up and running. Okay, so our RASA server is started. Let's just say hello. Okay, so as you can see, your NLU model classified hello with intent greet. So NLU, RASA NLU has classified input hello as the intent greet, and it also says that there are no entities. So, oh yeah, there were no entities in it. It's right. Is this correct? If we can say yes. Okay, so as you can see, next action the bot wants to run is action. Right now, the bot had run action listen when we gave the input hello. After the action listen, we gave the input hello, and the bot classified the input hello as intent greet with confidence 1. And right now, current slots we have is phone, which doesn't have any value right now. Okay, the bot wants to run utter ask phone. Is that correct? Yes. Okay, so once we let the code know that the utter ask phone is correct, it will run the utter ask phone with confidence 1. So here is our utter ask phone. Can I get your phone number, please? As you can see, our current slots still the phone number is none because we have not entered the phone number, and the bot wants to run action listen now. Is that correct? Yes. Okay, so now we have to enter a phone number. Can I get your phone number, please? Let me just enter a dummy number. Um, Okay, now as you can see, is the intent phone correct? Yeah, the intent was phone as we defined in our NLU. And in this intent, the bot is classifying this number as an entity number. Yes, that is correct. And it is asking us, are all the entities labeled correctly? We can say yes. Okay, so as you can see, till now, whenever it used to pop up a current slots, the phone slot was none. But now, after we entered the phone number, the bot extracted the number as entity number, and then it stored the number in the slot phone. This is it. And now you can see the slot phone has some value that we entered. Now the bot wants to run action save phone. We can say yes. So once the bot runs action save phone, our action server should get a request to run the action save phone. Let's just check here. Yeah, receive request to run action save phone and it was executed successfully. We'll go back to our RASA bot and see. So here it is. Your phone number is 01 for so this was the number that we entered. Yes. Okay, so that is how we extract entities and store it into the slots. And we even saw how to use the RASA LLM. Right now, there's no feature to extract the slots and entities using the LLM, but we can modify the stories to use the LLM in like as we modified here in the user. Say instead of intent, we put user, how is the weather today? We can we can just modify the intents for like we had the intent form. In that intent form, we had the input what is your name, so we can directly specify instead of the intent we can specify what is your name and all. But in that case we won't be we will need to have the NLU data because we can't because the bot won't understand the like which are the slots and which are the entities. So in that case, we need to have the NLU data. So right now, just that is the reason it is said that LLMs are used to make the bot intentless, but not completely not completely intentless, just to minimize the use of intents wherever necessary or wherever possible. So that's it. Thank you.